welcome back. Welcome to this section on Introduction to Object-Oriented Programming. The way you think in structured or procedural programming is completely different from how you would think in object-oriented programming. In this section, you will be introduced to thinking in terms of objects. We will discuss about what is a class, what is an object, what is state, what is behavior, and also discuss about a few important object-oriented basic concepts, encapsulation and abstraction. We will use a lot of examples to discuss about object-oriented programming and the different terminology which is used with respect to object-oriented programming. I am excited to bring this section to you. I'll see you in the next video where we would start with the basics of object-oriented programming. Until then, bye-bye. Welcome back to this video about Introduction to Object-Oriented Programming. Object-oriented programming is all about thinking in terms of objects. Before we get into depth with this, we will talk a little bit about structured programming. If you have done any programming with languages like C or Pascal, you'd be doing something called procedural or structural programming. Procedural or structured programming involves thinking in terms of procedures. These are also called methods or functions. So let's say I have a problem to solve. The first thing I would try and do is to split the problem into multiple functions or multiple procedures. I would start thinking in terms of, okay, what are the functions I would need to write? What are the different steps involved in doing this? For example, let's say I would want to fly. So I would want to fly from one place to another place. Then I would start thinking in terms of the different steps involved. I'll say, okay, travel to airport, find a check-in counter, check in, pass security checks. So we are thinking more in terms of what are the important methods that we would need to create and how to combine them to solve the problem at hand. Procedural or structured programming is all about thinking in terms of functions, or these are also called procedures. Object-oriented programming brings a new thought process around this. It says, okay, why don't we talk in terms of the different objects that are involved in the problem and also think about what is the data they would contain and what are the actions you can perform on them. Okay, is this sounding complex? Then you are not alone. That's how I felt when I was introduced to object-oriented programming as well about 15 years back. Let's take an example and try and understand how to think in terms of object-oriented programming. So let's take the example of taking a flight again. The first thing that we would be thinking about is what are the different objects that are involved. An airplane, an air hostess, a passenger, an airport, a cab that I would need to take to the airport, also the different persons that might be involved. So when we are thinking object oriented, we are trying to identify the different things that are involved in our problem. The first thing which we would try and do is to identify the things like airplane, air hostess, passenger, the pilot and things like that. Once we identify the things that are involved, we identify what data you would want to use about that specific thing. So what is the data that can represent an airplane? Maybe which airline, what is the make of the airplane, what is the type of an airplane, whether it's an Airbus or not, and what is the position, where is it currently. So that's kind of typically the data. And also you think in terms of actions. You'd be thinking in terms of the actions that you can perform on an airplane. Take off, land, cruise, a lot of things that you can do on an airplane. If you look at the air hostess, then probably the name of the air hostess address is the data. And there might be actions like wish, serve, and a number of other actions. When we are thinking about a passenger, his name, maybe his address, and a lot of information can be the data. And probably the actions he can perform is take cab, do a check-in, walk, smile, run, board the aircraft, and a lot of such actions. So when we are thinking object-oriented programming, we are thinking about what are the objects, what is the data they might contain, and what are the actions that can be performed on them. The data that an object might contain is also called state of the object. The state of an object can change over a period of time. The position of an airplane now is different from the position of an airplane maybe after an hour. The actions that can be performed on the object are also called its behavior. In summary, the big picture is this. Structured programming is all about thinking about procedures or methods. That's all we would be thinking about in structured programming. In object-oriented programming, we try and think in terms of objects and what kind of data they might contain and what are the operations or what are the actions that can be performed on these objects. If all this seems a little confusing to you, do not worry about it. We would be using more than 5 examples to discuss this in detail in this specific section. I'll see you in the next video. Welcome back. In this video, let's talk about what are the different terminologies which are associated with object-oriented programming. In the previous video, we learned that object-oriented programming is all about objects, the state of the objects and the behavior. What we are seeing in here is a simple class. This does not really follow the Java syntax. I just created a simple template kind of thing to just represent a class, and I'm creating 2 instances of the class in here. What is a class? A class is nothing but a template. A class can define what are the data that an object can have and what are the actions that can be performed on an object. A class is like a template. For example, a person is a class. An object is an instance of a class. So when we talk about person class, the instances can be Mahatma Gandhi, Nelson Mandela. So a person class defines the attributes that are related to a person, and each object of that specific class, each instance of that specific class, for example Nelson Mandela or Mahatma Gandhi, can have different values for the attributes of the class. Let's consider this example, right? So we have a planet class and we are creating 2 instances, Earth and Venus. You can have other instances as well, Mars, Jupiter. So this is a class which defines that a planet in general will have a name, location, and a distance from the sun. And Earth is a specific instance of that planet, and for Earth, the name is Earth, location is, let's say, specific coordinates of the Earth, and the distance from sun for Earth would have a different value compared to the other instance of planet, Venus. If you are aware of the solar system, then you would know that Venus, the distance of Venus from sun is less than that of the Earth from the sun. So the distance from sun for Venus would have a different value compared to the distance from sun for Earth. So a class is a template, an object is an instance of that template, Earth, Venus. The member data, state or fields are the data which are present in every object. So for each of these fields, Earth can have a different value and Venus can have a different value. So this is called member data, or this is also called the state of an object. This is represented by using something called fields, or these are also called member variables. The last terminology which is frequently used in object-oriented programming is related to the methods which are defined in a class. These methods are said to be representing actions that can be performed on a specific object. So you can say earth.revolve, earth.rotate, or you can say Venus rotate. So these are the actions that can be performed on different objects. This is called behavior of a class. Behavior of a class is the actions that can be performed on its objects. The idea behind this video was to give you a quick introduction to all the terminology related to object-oriented programming. So a class is a template, an object is an instance of that template. The member data is what data an object can contain, and behavior or actions are what are the actions, what are the methods that can be called on a specific object. Let's end this video with a few exercises. So think about an online shopping system and try and identify what are the different things that are involved in creating an online shopping system. So try and identify the objects, try and identify what kind of data would be associated with each object, and also what kind of behavior would be associated with each of those objects. And the second one is much simpler exercise. So think about a person class. Think about what can be the data which can be present in that, and also think about what are the actions that can be performed on it. So think about those two things. Those would be an interesting exercise as far as object-oriented programming is concerned. I'll see you in the next video. Welcome back. In this short video, we'll discuss about the exercises from the previous video, right? So the first thing which we talked about was the online shopping system. We wanted to identify the different objects that are involved and also the data associated with them and also the actions that can be performed. So here are a few examples. I mean, this is not really a complete master list as such. This is a representation of how you can think about them. I'm sure you would have identified much more than what I have shown in here. So the types I have identified are customer. A customer can have a name, address, and he can perform multiple actions, right? Log in, log out, select a product, check out, and a lot of other stuff, right? And shopping cart can contain a list of items that a customer has already chosen, and the actions you can probably perform on a shopping cart are add an item, remove an item, and things like that. Another thing is a product, right? So a product has a name, it has a price, quantity available. That's all the data, that's the state. And the behavior is what are the methods that can be exposed. Probably order more products, change the price of the product. All those can be the actions that can be exposed. Actually, this is just a small representation. Actually, when you talk about an online shopping system, you can identify a number of other objects and also you can identify what state they might contain and what behavior is possible on them. Now, let's get to the other exercise. The other exercise was to identify things related to a person. So there's a class called person. What is the data that you would want to have there? And what are the actions? What are the methods that you would want to have there, right? So these are a few examples. So name of a person, maybe you can even split it up and say first name, last name, and middle name. Address, you can even split it up again, right? So you can store the zip code, country, state, and all that kind of information as well. What kind of hobbies does this person have? Where does he work? Is he studying? All that is the data about a person, right? And the other thing is the actions that can be performed, right? So walk, run, sleep, eat, drink, travel, move, a lot of things that can be performed on the person. So the idea behind this exercises was to start getting you thinking in terms of object-oriented programming, right? So we are trying to identify the different objects that are present, what is the state, that is what is the data they might contain, and what is the behavior, what are the methods or actions that can be performed on them. That's a lot of theory that we talked about until now. I'm itching to get my hands dirty. In the next step, we would start creating a number of classes, creating instances or objects for them, and try and play around with them. I'll see you in the next video. Until then, bye-bye. Welcome back. After all the theory about object-oriented programming, let's get hands-on and let's try to apply what we have learned. So what we want to do here is to build a motorbike class. We would want to be able to adjust the speed of the motorbike and also the gears. So let's assume that this motorbike has a few gears, let's say 5 gears, and also you can press the accelerator to adjust the speed. So that's kind of the basic class that we would want to build. We would also want to create a few instances of this motorbike class, and we would want to create a couple of methods to be able to adjust the speed and gears as well. What we would want to do is, in this section from here on, whatever theory that we learned about class, object, state and behavior, we would want to look at it in practice and also look at the basics of encapsulation and abstraction. In this video, let's focus on creating a motorbike class, and let's create a few instances and play with it. We'll start off with creating a new project. If you are actually coming from the previous section where we ended it with a debug perspective, right now you can move to a Java perspective. You can do a window perspective, open perspective, Java. Java perspective is the best perspective to be developing things. What I'll do right now is do file, new Java project. I'll call this introduction to object-oriented programming. Now you can leave all the rest of this stuff as it is and click finish. This will create a new project, and when you expand it, you should see a source folder in here. That's cool. Now we can create our Java class in here. Do not worry about this readme.md. You will not see that. So over here, I can create a new Java class. How can I do that? Command N and type in class and choose class plus next. Type in the name of the class, right? So the name of the class I would want to call it is, we would want to create what? A motorbike. So let's do that, motorbike. So I'm using camel case, motor, bike, M caps, B caps. That's how we name our classes. Classes start with a capital letter, and except for classes, almost everything else like variables, methods, they would all start with a small letter. I mean, that's kind of the convention that is typically used in Java. Now the package, I'll say com.in28minutes dot introduction. I'll just call it oops. So com.in28minutes dot oops, and now I'd go ahead and click finish. Okay, cool. Then we have our motorbike class. So you'd see the package in here and you'd see public class motorbike. That's cool. Now let's also create a runner class for it. So I'll say control N, again command N, control N, or you can do file new class and type in motorbike runner. And in the runner classes, we'll create a main method. I'll go ahead and click finish. What we are doing in here is creating a class and its runner. In the runner class, what we'll do is we'll create instances of the motorbike and we will try to make use of it. So let's create a couple of instances of this motorbike. Let's call them Ducati and Honda. So how do we create instances of the class? Do you remember it? Try and pause the video and try creating two instances of the motorbike class. It should be very simple, right? So it's motorbike Ducati is equal to new motorbike. Isn't that cool? And motorbike Honda is equal to new motorbike. Okay, cool. Now you'd see one of the things which Eclipse does, which is to highlight warnings. So it's saying, okay, Honda is a variable which is created in here, but you have never used it. What we'll do now is we'll create a simple method in the motorbike. We would want to start and stop the motorbike. So let's say void start, and over here, what can we do now? I can call the start on both the things, Ducati.start and Honda.start. So that's cool, right? So now I can go ahead and run this. How do I run this? Right click, run as Java application. You'd see that nothing really happened. Why did the console did not come up? Because we are not doing anything in the start. So let's go ahead and do that. System.out.println bike started. Okay, cool. Let's go ahead and run this. You can do it as right click, run as Java application. You'd see bike started twice. So one of the things right now is we are not able to distinguish which bike has started. That's something which we'll fix very soon. In this video, what we have done is we have created a motorbike class with a simple start method. And we created a motorbike runner and we are now able to create instances of it and call the start method. Motorbike is the class, Ducati and Honda are the instances of the class, and the behavior of the class is the start. So you can start the Ducati bike and the Honda bike as well, because that's on the class. So whatever methods are on the class can be invoked by all the objects of that specific class. Now let's look at an exercise that you can do based on what we have learned in this specific video. Create a new class called book. So create a class called book, create 3 instances of it. The 3 instances of it are art of computer programming, effective Java, and clean code. So these are some of my favorite Java books. Actually, this is a Java book, this is a book on algorithms, and this is a book on how to write great code. So these 3 are among my favorite books. You need to create a class called book and create 3 instances with these names. Until next video, bye bye. Welcome back. Let's now work on the exercise problem that we discussed in the previous video. It should be very simple, right? It's very simple to what we did until now. So I'm doing a control N or command N, or you can do a file new, create a class. So I'll call this book and create it, and control N or class. So book runner. I would add a main method in here and click finish. And over here I can go ahead and create instances of the book, right? So what are the names that we would want to give to the book? Did you remember them? The names that we would want to give are here. So I'll just copy them over here. So this is the names that we would want to give. Art of computer programming. Let me remove these spaces. Art of computer programming. Okay, is this a good variable name? Good instance name? Good object name? Nope. The names of objects should always start with a small letter. So effective Java and clean code. Cool. This is cool. So all that we need to do is equal to new book, and I'll copy paste it here and say book and copy paste it in here. Okay, so those are the 3 instances of the book. Now we can go ahead and create a method in it. I'll leave that as a quick exercise for you. The important thing you need to learn is to be able to create classes very quickly, and how to create a main method very quickly, and also how to create instances and name them. So the convention which is used in Java is to name a class with a capital letter and name a variable starting with a small letter. And after that, it's always camel case. So for each of the words, start of the word, you'd use a capital letter. Until the next video, bye-bye. Welcome back. In the previous step, we created a few instances of the motorbike Ducati and Honda. These are objects, right? We said earlier that objects have state and behavior, right? So we said each object has state and each objects have behavior. Behavior or behavior, whichever way you would want to spell it. State is what is the current situation a specific bike is in. For example, I'm driving a Ducati and currently my speed is 50 kilometers per hour or 50 miles per hour. So what's my state? My state is that I'm going at 50 miles per hour. This state can change. So Ducati, let's say I accelerate further. What does the state become? My state right now is 70 miles per hour. So that's the state of an object. How do we represent state of an object? By creating variables inside the class. So in the class, we can create member variables. Here, we would want to have state of motorbike, and the state of motorbike I would want to have is int speed. Actually, for speed, even short should be sufficient, but let's use it. So int speed, this is the state of the motorbike. What we have done now is we have created an instance variable inside the motorbike class. Once you create an instance variable in the motorbike class, you can set values for it. So now I can say speed. How do I refer to the speed? Speed is a value inside here, right? So inside the class. Can I say motorbike.speed and set the value? What does it say? error. It says, okay, you cannot do that because speed is an instance variable. Instance variables can only be referred from instances, objects. So I can say Ducati dot speed is equal to, let's say, 100. And now I can also set Honda dot speed is equal to 80. So what we are doing in here is we are changing the state of the object. So we are setting a speed of 100 to Ducati and speed of 80 to Honda. And after that, the state can change as well. So let's say after some time, Ducati has reduced the space. There's a traffic jam and Honda has completely braked. He's taking a break. So this is basically how your state of an object can change across the duration of the program. Right? When we start off, we are starting the bikes, we have set the current speed, and after some time, the speed has changed. So similar to this, the state of any object can keep changing. One of the important things is Ducati has its own instance of the speed variable. Once we have defined a variable called speed in here, Ducati has its own instance, Honda has its own instance. If I say Ducati.speed is equal to 100, the speed of the Honda will not be changed. Honda speed will be changed only if I say Honda.speed is equal to and change that specific thing. So these objects are independent of each other and each of these get a copy of this specific variable. The way you can look at it is like this. So once I created an instance of motorbike called Ducati, a Ducati is created in memory with a space for the value for speed. And similar to that, a Honda is created in memory with a speed. So the motorbike is acting as a template. This template contains a variable called speed. So each of the instances of that template, each of the instances of that class, Ducati and Honda, have their own individual copies of this speed variable. So here what we are doing is we are setting a speed of 100. So we said Ducati.speed is 100. So that's cool. And now we say Honda.speed is 80. Honda.speed becomes 80. Now we are changing Ducati.speed to 20. So what would happen? The state changes 20 and Honda.speed is 0. So this is what is happening. So this is what happens in the memory when we create an instance of a class and change the state of it. In this video, what we have done is we have created an instance variable. So we created an instance variable called speed in the motorbike and we set different values for it. So we are changing the state of the objects. We saw how this is represented in memory. In this video, we are actually breaking a few good object-oriented programming practices. Don't worry about them. We'll fix all of that by the end of this section. I'll leave you with one exercise. What you can do is go to your book class and you can create a instance variable for storing number of copies of the book. So create an instance variable to store number of copies of the book and you can use the book runner and set different values for each of the book. So have different instances for Art of Computer Programming, Effective Java and Clean Code. I hope you're having a lot of fun with this. I'll see you in the next video. Welcome back. The previous exercise was to create an instance called number of copies. We did that and set different values for that. So this was a simple exercise. So I just wrote the code and I just thought I would show it out to you at the start of this video. So there you go. That's the exercise. And let's now continue with the topic for this specific video. One of the problems that we see in the motorbike class is that the motorbike runner class is directly accessing the value of an instance variable of the motorbike. This is not considered to be a good practice because this motorbike runner is a different class. So this is in a different class of its own and this class is directly accessing internal variables of this class. This breaks something called encapsulation. Encapsulation is the concept that only this class should have access to the data inside the specific class. All the other classes should access data through the behavior of the class, through the methods that the class offers. So the principle is that other classes should not be able to change the data of a specific class directly. If I have to change the state of a class, it should be through the actions, the methods that are performed through that specific class. This is one of the fundamental principles of encapsulation. Encapsulation is data and methods which access the data and set values to it. So all modifications to the data of an object should be through the methods of that specific object. Here what we are doing is we are modifying the data from outside. Let's now fix that. How do we fix that? The way we can fix that is by making this variable private. So when we make a variable private, what would happen is it cannot be accessed from outside this class. So outside the motorbike class, I will not be able to access this speed variable. What is happening here? You can see now that as soon as I put a private in here, it's not allowed to access it. There are a couple of other access modifiers that we will discuss a little later. For now, the important thing is when you put a private on a member variable, only that specific class will be able to access the value of it directly. This is now causing a compilation error. How do we fix it? Think about it. Pause the video here and think about how we can fix this. The way we can fix this is by adding methods which would expose this data out. What we can do now is create a method for setting the value of speed. So how should it look like? What should be the input? So we need to create a method, right? So for the method, what should be the inputs? Whenever we think about method, we should think about what should be the inputs, what should be the outputs, and what should be the name, right? So what should be the inputs, outputs, and the name. So the inputs of this method, what would be the input? The speed, the value of the speed. So it would be int speed. That's the input for this method. The output for that method should be what? What should be the output for that method? We are just setting the value, so we don't really need to do anything. So we'll return void. And the name of the method, because we are setting the speed value, we'll call it set speed. So let's create that method, void set speed and int speed. And what we can do now, we would want to set the value on the speed variable. Whatever is in here is a member variable. Member variables belong to the objects. So member variables are specific to an object. Over here we have another speed variable. This is a local variable of this specific method. So the argument to a method is almost like a local variable inside this method. So whenever we say speed inside a method, what we would be referring to is the local variable. So if you do a system.out.println speed here, let's do that, system.out.println, let's print speed. What we would be printing is the local variable. Now if I do system.out.println, I would want to be able to access this speed. So speed which is present in here, the way I can access that is by doing this dot speed. So whatever value is coming in here is speed, and whatever value is of the variable, it's this dot speed. Now what we want to do is we would want to set the speed of this specific thing. So the way we can do that is this dot speed is equal to speed. So whatever value comes into the method, we would want to set it to this. So what we want to do, when somebody calls dot set speed 100, we would want to take that value and set it to the instance variable. I'll remove this system.println for now. So what we are doing in here is we are creating a method set speed in speed. this dot speed, we are accessing the member variable and setting the value from the parameter or the argument. Over here, what should we do to fix this? Dot set speed 100. So we will invoke the method. So instead of directly setting the value, we would set speed 80 dot set speed 20 dot set speed 0. As simple as that. Now you might be asking me, okay, what is the use of this encapsulation? I'm only making the code more complex. So what is really the use of it? I'll leave it as an exercise for you to think about it. What is the use of encapsulation? We'll discuss that in the next video. Another exercise is to update the book class and make sure that it is not breaking encapsulation. I'll see you in the next video. Welcome back. In this video, let's look at the exercise and also the puzzles related to the previous video. The first thing is the exercise, right? So art of computer programming dot set number of copies 100. So that's how we would need to do it. First thing we do is make it private so that other classes will not be able to access it. And over here, we are actually setting number of copies, int number of copies, and we are doing this. This is number of copies is equal to number of copies. And we are able to set the number of copies from here. Now that's cool. That's your book runner. You can run this and see if it works fine. It should not be any different from what we did for the motorbike runner. Now let's shift our attention back to the motorbike. What we'll do now is we'll revise the concept which we learned in the previous video about encapsulation and also discuss a few puzzles. What is encapsulation? Encapsulation is basically protecting your object from other objects. You don't want other objects to directly change the data inside your object. What we'll do is we'll create methods around it. So we'll create methods so that other objects, other classes will only be able to use those methods. So if somebody wants to change the speed of a Ducati, they should use the set speed method. They cannot directly go and set the value of something which is private, which is the state of a motorbike. That's number one. This is the basic of encapsulation. There is more to encapsulation. We'll talk about it a little later. But for now, this is one way to properly encapsulate the data inside your class. So you might be having a question. So what we are doing here is we are setting a speed on a Ducati to 100. But let's say I would want to find out what is the speed of the Ducati in here. After this, what is the speed of Ducati? After this, what is the speed of the Honda? If I would want to find out, how do I do that? The way you can do that is by creating a getter method. So let's go ahead and create a getter method here. So a getter method would get the speed. So the way we can do that is by saying get speed. We don't really need to pass any input because we would want an output. What we would want to do is we would want to get an output. What is the output? Speed. What is the type of speed? Int. So int get speed, and what we would need to do here is say return speed. Return this dot speed. So we are using this to refer to this specific object. Inside the object, return the speed value. Over here, I can do system dot out dot print ln and say Ducati dot get speed. Cool, isn't it? So that's something which I could do. Here I can say Honda dot get speed. Make sure that you get the variable names right. So this is Ducati, this is Honda, and now let's print it. I'll remove the code after this. So set 20, set 0, I'll remove them. So let's have just this and let's run it. So you can see now that bike started and 180. That's cool, right? So we are getting the speed of Ducati and that's getting printed as 100, and here the speed of this is getting printed as 80. Now let's get to the cool part right now. So over here what we did is we manually wrote this, right? So we manually wrote the set speed, manually wrote the get speed. With Eclipse, the great thing is you don't need to do it manually. You can get Eclipse to generate it as well. So what I'll do is I'll delete this code. So I'll press delete. I'll highlight all the code that I would want to delete. So like I don't really need the comments anymore. So I'll remove both the set speed and the get speed methods. Now obviously when I save it, I would get a compilation error because these methods are not there. Now I can get Eclipse to generate it by doing a right click, source, generate getters and setters. So right click, source, generate getters and setters. And if you expand this, you'd see get speed and set speed. So because this is such a standard thing which we keep doing in Java, Eclipse provides an automated way of doing it. So now I can say, okay, cool. You can see that the get speed and the set speed method are automatically generated for you. And the code again compiles. Isn't this cool? You would have seen that earlier to create these methods we needed to spend some time, but now you can see that it's very easy to create these methods as well. So that's a cool feature of Eclipse. That's called code generation, and one of the code generation features is to generate getters and setters. So the way we got it is source, generate getters and setters. Now there are no fields that don't have getters and setters, so it says, okay, buddy, for all the fields you have getters and setters, so there's nothing I can do about it. So that's cool. That's the second thing that we wanted to talk about in this specific video. In the next video, we will dig deeper. There are a couple of other puzzles that are left out. So let's look at those puzzles as well in the next video. Welcome back. What we'll do now is look at a few puzzles related to whatever we have done until now. I'll comment out these two lines. So we're not printing the Ducati.getSpeed right now. What I'll do is I'll go to the setSpeed method, and in the setSpeed method, I would do a sysout, control space, and print speed and this dot speed. I will also comment out one of the methods in here. So Honda.setSpeed 80, I will comment it out. So now the exercise for you is to figure out what would be the output. So I'm doing a set speed motorbike, and I'm saying speed and this dot speed. What would be the output? Think about it. Pause the video here. Think what would be the output. Once you have decided the output, then play the video. Okay, let's run the program. Run as Java application. So it's printing 100 and 0. Let's see what's happening. This is 100 and this is 0. There are two important things that you need to note, right? So we are trying to set speed. So this method got, so Ducati is created. So over here Ducati is created, and immediately we are calling set speed. So the speed value which we are passing in here is 100. 100 is passed in here, and 100 is the value which is printed out. This dot speed is the default speed which is assigned. So until now we have not really set this speed for this specific thing. That's why it's printing a 0. The default initialization value for an int member variable is 0, and that's what you are seeing in here, and that's why it's printing 0. Now if I do it after this, what would be the output? Think about it. Let's run it again. Motorbike runner, please. Okay, it's 100, 100. So if I do it here, it's 100, 100, because over here the speed value is passed in as 100, 100. This 100 is taken and set as the speed for the motorbike, and that's why it's printing 100 and 100. So there are two important lessons that we learned with these two puzzles. The first one is that the initial value, so before this line of code, the Ducati speed is 0, and after this line of code, the Ducati speed would be 100. Now what would be the speed for Honda as it is right now? Think about it. What would be the speed for Honda? We have not changed the speed for Honda at all. So the speed for Honda would be 0. Let's do that. So let's try and print that out. So system.out.println honda.getSpeed. What would be the get speed? Run as Java application. It's 0. So if you comment out the honda.setSpeed, the default value which is present is 0. One of the things you can try and do is try and debug this as well. So what you can do is you can say set speed, and I can actually put a breakpoint in here. So you can actually go here, set a breakpoint, and do right click, debug as Java application. So it asks if I would want to start it in debug perspective. Yes, please. So now it starts up in debug perspective, and you can see much more information, right? So let's minimize. So I just need to double click. Again, I can minimize it, and I can see more information around it. So now you can see that I am inside. Where am I? So from the motorbike runner set speed, that's where we are right now, right? So this dot speed is equal to speed. What I'll do is, this might be a little confusing for you, so let's kill this. I'll set one more breakpoint actually to make sure you understand it perfectly. What I'll do is I'll put one more breakpoint down at the start. So at the start of motorbike runner, I have put in a breakpoint. Let's do a debug. So the debug is this one. So debug, which one do we want to debug? Motorbike runner. So now if I minimize this, I can see the things in here. Until now there is no variables here. So now I can do step over, which is function F6. So let's do a step over. What you'd see now is Ducati. A motorbike Ducati is created, and what's the speed of it? 0. That's the initial value which is assigned. So Ducati now has a speed of 0. Now I go and now the next line gets executed. What is this Honda? Speed is 0 again. So now we call the Ducati dot start. So bike started is printed to the console. Honda dot start, again bike started is printed. Now we are calling Ducati dot set speed. What I would want to do here is I would want to go into this code. So what I'll do is step into. So I'm do a step into. So we are inside Ducati right now. So we are inside the code for Ducati object. So there is a variable called this in here. This refers to Ducati object right now. And when I hover in here, you would be able to see that the speed right now is 0. The speed of the variable, so the variable here, the argument which is passed in here has a value of 100. But the speed of the Ducati until now is still 0. What you can do is step over this line of code. This line of code has not been executed until now. This has a speed of 0 and this is 100. So let's go ahead and do a step into. You can see that now this dot speed is also set to 100. So this dot speed is now having a value of 100. That's what the set method is supposed to do. Take the value from here and set it to this dot speed. And now you'd see when I do a step over, you'd go back, and now we can print the get speed of Ducati, right? So the get speed of Ducati, I'll do a step over. You can see that it's printing 100 because I called the set speed 100. The value returned back is 100. We did not call the set speed, it's commented. So what does it do? Step over, it prints 0. That's the default value. And step over again. That's terminating the program. In this video, we'll look at a couple of puzzles related to this and also the initial values for a member variable in the class. Until the next video, bye-bye. This video is part of a Java course with more than 250 steps helping you become an expert on Java. You can find the complete course details in the description of the video. Along with it, you can also find the details of a free PDF with 200 pages of awesome code examples in 28 minutes, creating great programmers.